Today we're going to add an LED to pin 40 and get it to blink every 2 seconds to act as a heartbeat monitor for the controller. So here you can see I've created a new flow called Pi Heartbeat. Again, to create a new flow using this here. And basically we have these nodes. Now you don't need the debug node, but I do use it just to check that the things are working. The first node we have is the heartbeat, which is an inject node, and this node, basically the only thing we want it to do is inject once after 1 second. We have a GPIO pin node. Now here you get to select which pin you want to use. So in this case I've chosen pin 40, which is GPIO 21, which is automatically filled in. We need to set it as a digital output. You could use the pulse width if you wanted. I've ticked the initial state because I want to make sure it's off. That's all that node needs to have done to it. To find that node, it's down here, so you choose an output or you can have an input. There's a couple of other things you can do, but for this demo I'm only using this one. Obviously the LED state is another debug node. Again, that just helps get this showing what is going on. But the main part is this function node, which you'll find, give me a sec, here. Now this is the first time you've seen me using the function node. This is where you do need to do a bit of coding. The code is quite simple. So here you can see we've declared a variable blink delay and we've set it equal to 2000 milliseconds. We then have another variable LED equals true, and then we've got a variable blinker and that equals set interval brackets blink comma blink delay. So it's using the time that we've set here. We've got a global dot set, which is blink. We've got a global dot set blinker comma blinker. Then in the function, which is the function we call blink, which falls into here, we've basically got an if statement. If LED and the message payload equals 1, LED equals false. Else, message payload equals 0, LED equals true. Now with this you can see as I hover over things it does sort of come up and tell you what it's expecting. So this variable has been set as a boolean. The final bit that is important is the node.send message, and then we have the final bit which is return. So as I say here you can see if I clear the debug, you'll see this is producing now an on statement, an off, an on and off. Now hopefully this has shown how we can quickly control an LED on pin 40 on the Raspberry Pi. If you can control the pin, you could use this for relays or other devices. And once again, thank you for watching. As I say, if you've got anything you'd like to see added or anything you want recovering, put a comment and I will answer it.